Hello YouTube viewers, hope you're all doing good. Welcome to this video. I'm Venkat and this is just me, an open source channel. Right, in this video I'm going to show you how you can deploy Redmine in your Kubernetes cluster. So Redmine is a web-based project management application. It's a web application. So I'm not going to show concept-wise, I'm not going to show anything new in this video. So I received a comment from a viewer that he was having problem deploying Redmine in his cluster. So I'm trying to help that user. So I've tried that in my test environment and it's working. So I'm just showing him how I did it, and I'm going to see whether it's going to help him overcome his issues. So concept wise, I'll be using Helm, deploying dynamic NFS provisioning, Ingress Controller, Let's Encrypt cert-manager. So those are the four concepts I'll be using in this video. By the way, all those four concepts have been covered in previous videos. I'm not going to show anything new in this video. As I mentioned earlier, this is just to help that user configure Redmine in Kubernetes cluster. So feel free to skip this video if you know about all those concepts. Okay, so we need Helm. I've got Helm installed already, Helm version. So we've got Helm. I've got dynamic NFS provisioning setup. I've got Ingress Controller, kubectl version minus minus short. So I've got version 1.15.0, which is latest, and my Kubernetes cluster is set up entirely using Docker environment kind, Kubernetes in Docker. I've also done a video on kind, how to install Kubernetes cluster completely using Docker containers, but I had to release this video before the video. I've already recorded that video for kind Kubernetes in Docker, but I had to release this one before that video. So anyway, I've used, if I show you kubectl get nodes, so you can see there's one master node and two worker nodes, Docker PS. So there are three Docker containers for these three nodes. So there's the master node as a Docker container and two worker nodes. So my cluster is entirely based on Docker containers. Okay, so kubectl get namespace. So I've deployed the dynamic NFS provisioner entirely in storage namespace. Kubectl minus n storage get all. So there is the NFS provisioner setup. I've got Nginx Ingress setup. Kubectl minus n Nginx Ingress get all. So that's Nginx Ingress namespace. And I've also got Let's Encrypt cert-manager setup using Helm. Kubectl minus n cert-manager get all. So everything is looking okay. And I've got a HA proxy load balancer running as an LXC container, LXC list. So that is HA proxy, and the IP address is this one. So I've got all the setups ready. I've covered all these concepts in separate videos. You can search in my channel. So now let's go ahead and then install Redmine application in our Kubernetes cluster. Okay, Helm search Redmine. So we have one Redmine in the stable repository. App version is 4.0.4. It's a flexible project management web application. So I'm going to download the values file and customize it. Helm inspect values, stable, Redmine, redirect that to temp, redmine.values file. And let's edit that file, temp redmine.values. Okay, so image repository tag pull policy, Redmine user is user, and I'm going to change the Redmine password. I'm going to set that to password. I'm going to leave email, language settings. I'm not going to configure any email options. Database type, so Mariadb is enabled, Postgres is disabled. You can use whichever database you want. Mariadb enabled true, so it's going to deploy a Statefulset for Mariadb, and replication is disabled. So in this case, it's going to deploy a Statefulset with just one replica. And if you want multiple replicas and for replication, you can enable this. In that case, it will create additional replicas in the Statefulset. I'm going to leave that as default. I don't need replication. This is just for testing. Database name, username, if you want to change the password for the root user, and so on, you can do that. Master persistence. I've enabled persistence because I've got the dynamic NFS provisioner setup, so I should be good to use. If you don't have NFS provisioner setup or any dynamic provisioning setup, you can change that to false to disable persistence. That's for development or testing purpose. But if you want to run that in production, it's advisable to enable persistence. Access mode, read write size 8 gig. I'm going to change that to 1 gig. Okay, so this persistence is for MariaDB database server. Postgres is not enabled. Let's leave that. And external database, if you don't want to use MariaDB or Postgres, and if you've got an external database set up already, you can um, specify the host name, username, password, and so on. Okay, so since we are using the MariaDB stateful set, I'm going to leave that as default. Service type, load balancer. So you can use Metal LB. I've done a video on that. In that case, you can just leave it as load balancer. But this user was having problem with the ingress setup, so I'm going to change that to cluster IP. Cluster IP because the service doesn't need to be exposed outside, so it needs to be exposed within the cluster. So I'm changing the type to cluster IP. And I'm going to use Ingress to route the traffic internally to this cluster. Okay, node port, I'm not using node port. And Ingress enabled is false, which means it's disabled. That's okay because I'm going to configure Ingress on my own. And then finally persistence. So this is for the Redmine app, not for the MariaDB. So we've enabled persistence for MariaDB earlier in this file. So now it's for the Redmine app itself. And the size, I'm going to change that to 1 gig. And that's all. Save the file, Helm, install. Let's install it. Minus minus name, Redmine. Give it a name, otherwise it will generate a random name. Stable, Redmine, minus minus values. The values file which we just edited is redmine.values. Press enter and you can see it has deployed a couple of config maps, a persistent volume climb, and a couple of pods, one for MariaDB and another for the Redmine app. And it has created a couple of secrets and a couple of servers, one for the MariaDB service and the other for the Redmine app, a deployment and a stateful set. So Redmine app is set up as a deployment with one replica, stateful set. MariaDB is deployed as a stateful set with one replica because we didn't enable replication. Okay, cool. Let's have a look at our default namespace. kubectl gets all. Okay, so it has already started running. It's already in the running state. That's good. And there you go. The service for MariaDB and the service for Redmine is called Redmine-Redmine. It's of type cluster IP and the port exposed is 80. So we'll just wait for the status to change to ready. The containers are running, but it's not in the ready state. Okay, let's do the check again. kubectl get all. Okay, so our MariaDB stateful set is ready, and we have to wait for the Redmine app. kubectl get all. Okay, so still it's doing something. kubectl get all. All right, let's check it now. kubectl get all. Okay, cool. So our pods are in the running state, so we are good to test it. So since the service is of type cluster IP, we don't have access to the cluster outside of the cluster, right? So now I'm going to set up a ingress resource. So let me clone my GitHub repository. Git clone https github.com/justme and open source/Kubernetes. I'll put the link in the description. Cd to Kubernetes and then cd to YAMLs, cd to ingress demo. So these are the manifests that I used when I actually did the ingress demo, the Nginx Ingress demo. So there are a couple of ingress resource manifest file which I'm going to reuse. It's still valid. Okay, before that I'll show you the persistent volume claims. kubectl get pvc. So we have two persistent volume claim, one for the Redmine app and another for the Mariadb database, and they're all bound kubectl get pv. So those are the two persistent volumes. The storage class is managed NFS storage. So if you want to follow my dynamic NFS provisioning video, you can. Basically, I did that. So the persistent volumes got created automatically. Okay, so now I'm going to edit a sample ingress file. vi ingress resource 1.yaml, for example. So that's a sample ingress file which I used in my Nginx Ingress demo. Let's change the name to Redmine-ingress. Let's change the host name to redmine.example.com. The service to root. So we are creating an ingress so that when our request comes into redmine.example.com, it needs to, the ingress controller will route the traffic to the service called redmine-redmine, redmine-redmine, and to the port 80. Okay, save and close the file. So the service is here. So this is the service that we need to route the traffic to whenever a request comes to redmine.example.com. kubectl create -f. Okay, ingress created. kubectl get ingress. So we have got the Redmine ingress. Let's describe it. kubectl describe ingress Redmine ingress. Okay, so the host is redmine.example.com and the backend is the service redmine-redmine and on the port 80. So you can see configuration for the ingress was added or updated. So our ingress is ready. So the final thing is the you are accessing redmine.example.com from the load balancer. So you're hitting the load balancer, and the load balancer will load balance between the worker nodes. So sudo vi etc host. So you're going to make a entry for redmine.example.com pointing to the IP address of your load balancer, which I've already done. So 1092.250.167 is the IP address of my load balancer, which is a HA proxy running in LXC container, and it's redmine.example.com. LXC list. So that's my HA proxy load balancer that has got the IP address. So let me log into the HA proxy machine, LXC container. LXC exec HA proxy bash. I just want to show you my HA proxy configuration. So if you followed my Nginx Ingress video, I've showed you how to edit the HA proxy configuration. But for those of you who haven't watched that video, here is the configuration. etc HA proxy.cfg. If you go to the very bottom of it, so that's it. So front end, so the load balancer is listening on port 80, and the default backend is this one. Balance is round robin. Each request goes to each node. So server kworker1, server kworker2. Don't worry about the server name. It has to be unique. That's it. And the IP address of the worker nodes 172.170.0.2 and 172.17.0.3. Okay, so that's all I have. Systemctl restart HA proxy, exit out kubectl get nodes -o white. So as you can see, kind worker 1, kind worker 2, those are the two worker nodes, and the IP address is 172.17.0.3 and 4. So the load balancer, the HA proxy load balancer will load balance the requests between these two worker nodes. So we are good to go. We have added a DNS entry to the etc host file for redmine.example.com. Okay, time for testing. Redmine.example.com. Cool. So that's your Redmine web application. So I don't have any experience using this project management web tool, but it looks very plain. Okay, so there is a sign in button here. Sign in, username is user, and the password is password, because we changed the password in the values.yaml file during the deployment. Login. Okay, there we go. Projects. There is no project. Let's create a new project. Give it a name, just me and open source. Click create. Okay, project is now created. You can add members to it. New member. There's no new member, so if you want, you can add new members, additional members. Calendar, news, documents, wiki, files, settings. So I don't know anything about this tool, so I'm not going to go show you a tour of this tool. So the idea of this video is not about Redmine itself, but how to deploy Redmine. Okay, so let me close that and go back to the terminal. So what have we done now is we've used the Nginx Ingress Controller to route the traffic to the service Redmine, um, and the load balance is between the two worker nodes. That's how it should work. And if you want to set up a HTTPS site using Let's Encrypt, I'll quickly show you how you can do that. But for that, you need to change your HA proxy configuration, because at the moment it's listening on port 80. We need to make it listen on port 443, and we need to make the SSL termination at the worker node, not at the HA proxy. Okay, let me delete the ingress. kubectl delete ingress Redmine ingress. So that one is deleted. kubectl get all. So still we have the service as type cluster IP. I've got the Let's Encrypt cert-manager setup. If I go to one level above into the YAMLs directory, cd to cert-manager demo. So I've got these manifests and configuration files. I used this when I did the video on the cert-manager. If you followed that video, you should be knowing about these manifest file. For those of you who didn't watch it, I'm just going to use that in this demo. So the first thing to do is to change the HA proxy configuration. Let's see what the proxy configuration looks like. Cat haproxy.cfg. So there's a front end and it's listening on port 443. And the following two options are important. Mode, you need to set that to TCP. If you don't set that, your request to redmine.example.com will be expecting a certificate on the load balancer, but we haven't got certificates installed on the load balancer. So we are proxying the request. Whatever comes into port 443, we are just forwarding. It's a plain proxy, forwarding it to one of the worker nodes through load balancing. And the load balancer and the ingress controller in the worker nodes will take care of the SSL termination certificates and so on. So for that, mode TCP is mandatory. And the default backend server, and you need to add the IP address of your worker nodes here. So how many worker nodes you've got, you need to add an entry for each of your worker nodes for the load balancer to work. Okay, so let me copy that. Control C. I'm going to log into my HA proxy node and edit the HA proxy configuration. haproxy.cfg. Go to the end of the file. I'm going to delete the default frontend and backend, and I'm going to paste that one. Okay, so IP address of my first worker node is 172.17.0.3, and the IP address of the second worker node is 172.17.0.4. Save and systemctl restart HA proxy. Done. But before that, let me also show you netstat minus nlcp, and now it's listening on port 443. That's good. Okay, so there is a ingress resource here which I'm going to use. Ingress resource.yaml. The first thing I want to do is change the name to redmine-ingress. Cert-manager, this annotation is important, so this is what takes care of creating and installing the certificates. TLS, and the host name is redmine.example.com. Again, the host here is redmine.example.com. Backend service is redmine-redmine. Port is 80. Okay. kubectl create -f ingress resource.yaml. So ingress resource created. kubectl get ingress. Okay, so you've got two ingress, one for the certificate, another for the Redmine app. kubectl describe ingress Redmine. So there you go. Create certificate. Successfully created certificate. Let's encrypt staging, and we should be good to go now. Okay, so cat etc host. So we've already got the DNS entry added to our etc host file. And now if we go back to the terminal and type https colon redmine.example.com. There you go. So that's your Redmine web application. If you want to look at the certificate, it's issued by the cert-manager. Okay. I think that's all I wanted to show you in this video. The user who asked for this is, I think his name is Kanzari. Hi Kanzari, I don't know how to pronounce your name, but see if this helps. If not, just come back to me and I'll see what we can do to get your issue resolved. Okay, so hopefully for others, you found this video useful. If you find it useful, please share it with your friends and make sure to subscribe to my channel. I've got lots of videos in the pipeline, and there are already 4 or 5 videos waiting to be released in the coming weeks, and I've got plans to do lots of videos in the backlog. So if you're interested in any particular topic, just ping me and I will add it to my backlist. But bear in mind, I will be releasing videos once every week during on Mondays. So as I've got like 4 or 5 videos waiting to be released, and I've got another 7 or 8 topics in the backlog. So if you request a topic, then it might be like 2 or 3 months away. Okay, so bear that in mind, and thank you so much for your time watching this video. I will see you all in my next video. Bye bye.